Welcome to Module 9.9, Absolute Value Equations. So in this lecture video, I'm going to show you how to solve what we so-called the absolute value equations. As you can recall in Module A, absolute value is referring to the distance, okay, from 0. So if I have an absolute value of 4, my answer will always going to be positive 4 because absolute value is about distance. There's no such thing as negative distance. Okay, if you back your card up 4 miles, it will still say positive 4 miles on the odometer. So if I have absolute value of a negative 4, my answer will still come out to be positive 4. Okay, so whatever comes out of absolute value is always positive. So looking at this from a different point of view, if I have an x inside the absolute value that's equal to 4, okay, then what can this x be? Well, this x can technically be a positive 4, or it can be what? A negative 4. So when we setting up equations using absolute value, if this c is greater than 0, so whatever's on the other side, the equal sign of the absolute value, it always got to be positive. If absolute value of x is equal to c, then x is equal to c, or x is equal to negative c. Okay, so what that means is this x, okay, once I strip away the absolute value, that x we can set it equal to a positive 4, or we can set it equal to a negative 4. Okay, normally the signs, okay, normally what I can put inside this absolute value technically is a positive or a negative. So instead of having the positive negative sign go with the variable, we actually put them on the other side. Okay, so that's the reason why when I first wrote my x, it's actually referring to a positive x equal to negative 4. Okay, that's what these definition means. So rather than having a negative sign on the variable, we put it on the other side, on the constant, the other side of the equal sign. All right. So if I have an absolute value of ax plus b is equal to c, then I will just simply take whatever I got inside the absolute value equal to a positive c, or I can also take whatever I have inside the absolute value set equal to negative c. So mathematically, it's technically a negative parenthesis ax plus b. Lord, too ugly. Technically, is negative parenthesis ax plus b is equal to that c that's positive on the right side. So rather than having a negative on the with variable term here, I'm going to divide both sides by -1. So in a way, I'm push my negative sign to the other side on the c. That's why the c on the other side is negative. All right, so that's the idea how we're going to write out our equation. So basically, whenever I have an absolute value equation, I always need to set up 2 other equations without the absolute value sign. We set one of them to be a positive constant on the right, the other one to be a negative constant. Alright, so let me show you how to do this particular problem in 4 different steps. Rewrite the equation above in standard form. Standard form means as isolate the absolute value term, okay, on one side of the equal sign. Everybody else need to be on the other side. So for this problem, the first thing I'm going to do, since the left side has 2 terms, right? My addition sign is outside the absolute value. I will move my positive 5 over. That will give me 3 times absolute value of 2x minus 5 is equal to positive 5 come over, become negative. That will be 6, right? 11 minus 5 is 6. Alright, my absolute value term is not yet by itself because I have 3 times up front, so I divide both terms by 3. So that will be absolute value of 2x minus 5 is equal to 2. Alright, so that's my standard form, and I need to determine if there's a solution. Yes, I will have a solution because this number on the right side of the equal sign is a positive. So I only look at this number on the right side of the equal sign after I isolate the absolute value term. Okay? Now use a definition of absolute value, convert the standard form of the given equation into two equations without the absolute value signs. So that means I will take whatever I have inside the absolute value, set it equal to a positive 2, that's on the right side, or I will set whatever is inside the absolute value equal to a negative 2. Okay, because set one is positive on the right, the other one is a negative. Now using the two equations found in the step number 2, enter the solution set using set notations. Okay, so using set notations, what that means is rather than using interval notation is used to describe a range of solutions. Okay, a lot of answers. An interval were the answers. All right, set notation that we are using right now is only for equal signs. So let me move this negative 5 over. That gives me 2x equal to 7. So x equal to 7 over 2. That's one answer. The other answer, move the negative 5 over. That's 2x equal to 3. So divide both sides by 2. X equal to 3/2. So that's my two answers. But I need to write them in set notation. So my answer will be inside my brace. Remember we said brace is the word set, and in there I will have 3 over 2 comma is separating my two answers. The other answer is 7 over 2. We can write it this way. Now I just have to graph it. 3/2 is about 1.5, so that might be somewhere between 1 and 2. I'm just gonna put a dot right there for 3.5. That's what you would do. Move the cursor on the homework to reach 3.3/2. 7/2 is about 3.5, so that's about if this is 3.5 will be about right here. Okay. All right, let's try other ones. So before you write two separate equations, make sure you isolate your absolute value term. Okay, got to do it in this order. Move the negative 8 over. That's 2 times absolute value of y minus 4 equal to 8. To isolate the absolute value term, divide both sides by 2. So absolute value of y minus 4 is equal to 4. So once the absolute value term is by itself, then the next step is set them up as two separate equations without the absolute value. So that will be y minus 4 equal to that positive 4. Or I'm going to take my y minus 4, set it equal to what? The negative 4. Okay? Because remember, what I can put inside the absolute value is a positive 1 and a what? A negative 1. Okay? Negative 1 type of numbers. That's why when we strip off the absolute value, we got to set one as a positive on the right side, the other one as a negative on the right side. Alright, let's go ahead and solve it. One of them, negative 4 come over, become positive. Y is equal to 8. The other one is y equal to 0. Put them in the set notation. That will be 0, 8. Normally I just put small answer in the front. Alright, let's take a look at this example. Alright, so I got to isolate the absolute value term first. So this extra term on the left side need to be moved first. That's 3 times absolute value of x plus 10 equal to positive 2 will come over, become negative. 3 minus 12 is negative 9, and we can stop it right here. Because whatever come on the absolute value cannot equal to a negative. So this is no solution. Can never equal to a negative, okay? Now what happens if I got two absolute value equal to each other? Well, basically we're just gonna say we're just gonna have, we're still gonna set up the same way. One of them is positive, the other one is negative on the right side. Okay. So since both my absolute value term is by itself, I'm just gonna take whatever is inside the absolute value, set it equal to the positive, okay, 5x over 8 plus 2. All right, the other one is gonna, see right here, the other one we're gonna do, take whatever is inside the absolute value, set it equal to a negative, okay, of whatever that I have on the right side, which is another absolute values, which when I strip it, that's 5x over 8 plus 2. Okay, a lot of students ask me, Mr. Chen, why don't you use the 5x over 8 plus 2 and make the other side a positive one and a negative one? Yes, I can do that. What I cannot do is to actually make both sides negative, because both sides negative turn out to be positive, which doesn't make sense because you already got one that is what, positive. So normally I just choose the right side one to make them what, positive and a negative. All right, so here I am going to clear the fraction real quick, which is, my LCD is 8, so I'll multiply every term by 8. So when I times 8, 8 means a over 1. So the a on top, 4 in the bottom, reducing to 1 and 2. So this is 2x. Negative 3 times 8, negative 24. Set it equal to top 8, bottom 8 cancels out, is 5x equal to, and plus 16. 2 times 8 is 16. Move the 2x over to the right, that become 3x, right? Become minus 2x. Positive 16 move over, become negative. So negative 24 minus 16 is going to be negative 40. Make sure I did it right. Yeah, 10, 2, 3, 4. Divide both sides by 3. My answer, x equal to negative 40 over 3. All right, the other side, since I'm setting the right hand, the other equation, since I'm setting the right side to be negative, so that'll be negative 1. We'll need to do a distribution, so that will be x minus 4, excuse me, x over 4 minus 3 equal to negative 5x over 8 minus 2. So if I multiply every term by the LCD again, like I did earlier, all the numbers instead stays the same, it's just a sign change. This is going to be 2x minus 24, but this is going to be negative 5x minus 16, right? Sign will change. So this time I'm going to move my negative 5x to the left side. That becomes 7x here. Move it, combine all at one time. Negative 24 move over, become positive. So negative 16 plus 24. Or we can say 24 minus 16, which is 8. Divide both sides by 7, x equal to 8 over 7. So my solution set, negative 40 over 3, comma, means separate the two answers. The other answer, a over 7. All right. So in this lecture video, we talk quickly about how to solve absolute value equation using an equal sign. So in module 9.10, we will begin to solve absolute value equation using inequality. All right, that will conclude this lecture video. Thank you for watching.